Hey, thanks for joining me today. We're going to talk about operations with mixed numbers. We're going to focus on mixed numbers in the context of algebra. And so one of our big messages is going to be that mixed numbers is a bad form. Putting things in the mixed number form is bad. And here's why. Mixed numbers have two parts. There's a whole number part, plus there's a fraction part. So an example here on the page is 2 and 5/8. 2 and 5/8 means 2 plus 5/8. But when you see it written down and you're thinking algebraically, it looks like 2 times 5/8. So that's one reason that mixed numbers are not the best form for these types of fractions. The second reason is that you can't do your multiplication and division operations, at least not easily, with the mixed number form. You have to change them to improper fractions. So we're mainly going to focus today on changing mixed numbers into improper fractions and then dealing with them. But we'll do an example of changing them back, and then we'll do some examples with addition and subtraction that illustrate kind of the difficulties and the what can and can't be done with mixed numbers there. Okay, so the first thing is we recognize that 2 and 5/8 means 2 plus 5/8, which means that we have an addition problem, and when you're adding fractions, you have to get the denominators to be the same. And the denominator of the 2 is 2 over 1. The denominator of the 5/8 is 8, so we're going to multiply 1 times 8, so the denominators will be the same. And we'll multiply the numerator, 2 over 1, by 8 as well, so that the fractions are equivalent. So 2 times 8 is 16, and 1 times 8 is 8. 16/8 is 2 plus 5/8. And now the denominators are the same. We can add the numerators together. 16 plus 5 is 21, and we keep the denominator 8. Now you may have seen a shortcut that everybody does, and this is a fine shortcut. It goes like this. You take the denominator times the whole number. Okay, this is multiplication. And then that answer is added to the numerator, addition. So 8 times 2 is 16, plus 5 is 21, and then you keep the denominator 8, and that's how you change from a mixed number to an improper fraction. Notice that it's the same thing we did, kind of an expanded form where we change the denominator to 8, and the numerator gets multiplied by that denominator, common denominator as well, and then we add the two numerators together, the 16 and the 5, to get the 21, and we keep our common denominator, which is 8. So it's the exact same thing. This is the proper way to think about what we're doing, but that shortcut is pretty nice when you're trying to do your math fast. Okay, now let's change the question around and say, what if we had 23/7? That is called an improper fraction. The top number, the numerator, is larger than the denominator. So this can be written as a mixed number, and so we want to do that. We want to change this to a mixed number. How do we do this? Well, we remember that 23 over 7 means 23 divided by 7, which can be written as 7 into 23. Now, this is the way we're going to think about it. How many times does 7 go into 23? How you do it, practically speaking, is up to you. This long division is a great way to do it. You can do it some other way if you want to. 7 goes into 23 3 times, because 7 times 3 is 21. That's a little bit less than 23, but you can't have any more 7s in there. 23 minus 21 is 2. And so we would say in long division, 3 remainder 2 is the answer. 23 divided by 7 is 3, remainder 2. Well, what does that really mean? Well, that means 3 wholes plus 2 sevenths. 3 wholes plus 2 sevenths, or 3 and 2 sevenths. That is the mixed number form of 23 sevenths, which is in improper form. Okay, so that's how you go from mixed numbers to to improper fractions, and improper fractions to mixed numbers. Okay, now for the next couple of problems, we're going to practice multiplying and dividing, and the rule for that is we have to have our fractions in our mixed numbers in improper form. So the first thing, number one, is put all the mixed numbers into improper form. Can't do this without doing that. So I'm not going to try to do this multiplication in any way. I will mess myself up if I try to do any multiplication before I change the question so that there's no mixed numbers. So the first one, 5/9, is not a mixed number, but the second one, 4 1/5, is. So I'm going to write 5/9. I'll put it in parentheses, just kind of keep it separate. And then 4 1/5, I'm going to do that shortcut. I'm going to take 4 1/5, and I'm just going to do this little multiplication. 4 times 5 is 20. Then addition, add that to the numerator. 4 times 5 is 20, plus 1 is 21. Keep the common denominator. Remember, I just took 4, and we said there's 20 fifths in 4, plus the 1/5 is 21 fifths. Now, I'm going to show this as a separate problem, but you can work it out. You can work out the multiplication. Now, this is just multiplying fractions. We multiply the numerators together, multiply the denominators together. I'm going to write the combined numerators as 5 times 21, which is 3 times 7. And the combined denominators is 9, which is 3 times 3, and then times the 5. So I have all my factors from both numerators on top and all my factors from both denominators on the bottom, which allows me then to clearly see that there's a 5 in common and a pair of 3's, and then what's left over is just the 7 in the numerator and the 3 in the denominator, so 7/3. And that is my preferred answer. I like this answer. But if you want to, you can take it one step further. You can say, well, 3 goes into 7 2 times, with 1 left over. 2 times 3 is 6 out of 7. So there's 1/3 left over. And so 2 1/3 is the mixed number form. 7/3 is the improper fraction form of the answer. For my purposes, for me, I would say that reducing these fractions is very important. And the form that you use, not so much. I would just as soon keep it as an improper fraction. Mixed numbers are not useful unless you're at the end of the problem and you're giving you the answer in words. Like the question is, how many inches is it? Saying 7/3 of an inch is a little more confusing than saying 2 1/3 inch. So that's when I would use mixed numbers. But otherwise, I would keep all my fractions as impropers. Okay, let's do that same problem only as a division problem, and notice I have that here. It's 5/9 divided by 4 1/5, so I didn't even change the numbers. That was lazy of me. I'm going to just do that first part. It's the same, 5/9 divided by improper fraction form, 21 fifths. Now again, it's really important that you take the time to change your mixed numbers to improper fractions, and you just focus on that only. Don't get ahead of yourself. So I'm not trying to interpret what I'm going to do next. I'm just writing it out in improper fraction form, and then I'll interpret, like, what am I doing here? I'm dividing. Remember, dividing a fraction means multiplying by the reciprocal. So now I can apply that. I can start thinking about that. So 5 ninths divided by 21 fifths is the same as 5 ninths times 5 21s, 5 over 21. Okay, and then I can think about the factors. Well, 5 times 5 on top, and 3 times 3 is 9, and 3 times 7 is 21. So notice that this time there's no common factors because I flipped the fraction over and ended up all the like terms are on the same side, numerators or denominators. So 5 times 5 is 25, and 9 times 21, or 3 times 3 times 3 times 7 is 189. This is not an improper fraction. Notice the numerator is smaller than the denominator. So we don't have to worry about changing it to a mixed number because it can't be written in a mixed number form. It's a fraction less than 1. So 25 189ths. Notice that we already looked here to see if there were any common factors between the numerators and the denominators. And there weren't, so there's not any common factors in the final result. So that 25 over 189 cannot be reduced any further. So we're good. We're good to go. And that's a little review of multiplying fractions. Okay, now let's talk about addition. And I'm going to do 3 problems here. I'm going to show you, the first one's kind of easy. I'm going to show you how we do this. And the rule, remember the rule for multiplication and division was put it in improper form. The rule for adding and subtracting is it's probably easier to keep it in fraction form, but you have to remember what you're doing. And the way I'm going to teach this is I'm going to show you a problem. Let me just pretend this is a decimal. So let's say 10 and 13/14 is really 10.8. Okay, where did I get the 8 from? Well, I just made it up, but notice that that's a really big fraction. 13/14 is really close to 1, so 10.8 is close to 1. Minus 4/7 is a little bit more than 1/2, so 3.5, let's say. In this situation, when we're subtracting decimals, and we haven't done this in this class yet, but I think you probably remember, you line up the decimal point, and the part that is the decimal, the number less than 1 part, is going to be subtracted. 8 minus 5 is 3. And then we bring down the decimal, and then the part that's the ones place is going to be subtracted. 10 minus, or 0 minus 3 can't borrow from the tens place. So we borrow the 1, becomes a 10 minus 3, which is 7. But what we did here is we took the whole number parts and subtracted those. We took the decimal parts and subtracted those. Well, decimals and fractions are the same thing, and that's what we're going to do. We're going to take 10 plus 13/14 minus 3 and minus 4/7. So we're going to do the 10 minus the 3 and the 13/14 minus the 4/7. And then we'll get our 2 different types of answers, right? One will be whole numbers, right? 10 minus 3 is 7 still. But 13/14 minus 4/7 is something, some answer, and we'll write that here. This is going to work because the 10 was bigger than the 3, and the 13/14 we think is bigger than the 4/7. We're estimating, but I think that'll bear out. This is going to work. I'll show you one that doesn't work, and then we'll have to do something different. Okay. So in order to do the subtraction here, we have to do that 13/14 and the 4/7 have to be the same denominator. So I'm going to multiply the 7 by 2 to make it 14, and then multiply the top by 2 as well. So this becomes, and I'm going to write it in a separate color, this becomes 13/14 minus 8/14, which we can now do. 13/14 minus 8/14, notice 13 is bigger than 8. So we can do the subtraction. 13 minus 8 is 5. So this becomes 5 14ths, and there's our answer. Okay, now that was actually, it's kind of complicated looking, difficult, but it was fairly easy because we were subtracting the whole number parts from each other and subtracting the fraction parts from each other. But it only worked because the first number, the one we're subtracting from, every part of it was bigger than every part of the second number. Okay, in just a few minutes we'll do another example where that's not true. But let's shift over to addition, just so you can see that this works with addition. I'm gonna do it vertically again, so I'm gonna write 5 plus 5/8, and then this time it's plus 2 plus 3/6. And I can do 5 plus 2, that's easy. 5 plus 2 is easy. But the 5/8 plus 3/6 we can't do yet because the denominators aren't the same. So I'm going to work that out. Now think about this. 8 is 2 times 4, and 6 is 2 times 3. So the LCD, the least common denominator, isn't going to be 6 times 8. It's going to be 2 times 4 times 3. Right? So I need to do times 3 to the 8 and times 4 to the 6. So I get the LCD, which is 2 times 4 times 3, which is 24. So 3 times 8 is 24. 4 times 6 is 24. And so the problem becomes 5 plus 15 24ths plus 2 plus 12 24ths. We're going to add those together. 5 plus 2 is 7. And 15 24ths plus 12 24ths, the denominators are the same, so now I can add the numerators. 27 24ths. Now, here's the big problem with addition and mixed numbers. I added the whole number parts, fine. I added the fraction parts, fine. But I ended up with a whole number and a fraction that is an improper fraction. And we don't want that. We definitely don't want to mix numbers and improper fractions. So I'm going to have to rewrite this so that I can get the whole number part of my improper fraction combined with the whole number part that I already have here, 7. So this is going to be 7 plus 27 24ths. Well, there's 1 24th in 27 with 3 left over. And so 7 plus 1 is 8. And 3 24ths, and that can be reduced. I can think about it as divide by 3, top and bottom, or I can think 24 is 3 times 8. So 8 and 1/8 is my final answer. So the trick for adding is you have to watch out if you're adding the fractions together and you get your common denominators, and you add them together and you end up with an improper fraction. You have to turn that into a mixed number so you can combine all the whole number parts together. Okay. Now, it is true that we could have just turned these both into improper fractions, added them together, and have an answer in improper fractions, and that would be fine. The problem with that is that you end up with really big numbers. This would be 65/8, which is true, but since you didn't have to do that, we say it was a little bit easier to do 5 plus 2 than it was to turn the 5 into 24ths and the 2 into 24ths and add those big fractions and then reduce them. So I think it's easier to keep them in mixed number form when you're doing addition and subtraction. We may change our mind on this last one here. Let's see. Okay, let me just go through real quickly the kind of the little test we did before. Remember before we said 5 and 2/9 is, let's say that's like 5.3. I don't know what it is. And minus 3 and 5/6, let's just say that's 3.9. Okay. Now, in this case, if we were subtracting it was decimals, you remember that you would say 3 minus 9. Oh, can't do that. the big mistake everybody makes here is saying, oh, well, 3 minus 9 is 6. Of course, that's not true. 9 minus 3 is 6, but we're not subtracting from bottom to top. We're subtracting top to bottom. So 3 minus 9 can't be done. We have to borrow from the 5, make it a 4, and then add 1 to the 3, or add a 10 to the 3, we say that's 13. And then 13 minus 9 is 4. Bring down the decimal point. 4 minus 3 is 1. So 1.4 is the answer that we get for these made-up numbers that are similar to the fractions, the mixed numbers I started with. But I just wanted to show you that in decimals we have to borrow sometimes from the higher place values in order to be able to do the subtraction, and that's what's going to happen here. We have 5 plus 2 nines minus 3 and minus 5, 6. So it's 5 minus 3 and 2 nines minus 5, 6. We're going to have to subtract here, but notice that 2 nines minus 5, 6 is not going to come out right because 2 nines is less than 5, 6. If I was to do that subtraction as is, it would be I would end up with a negative number. So instead, here's what I'm going to do. And I'm going to kind of walk this out, but you might find shortcuts for this. Okay, so first we're going to try to get the LCD, the lowest common denominator on our fractions. 9 is 3 times 3, 6 is 3 times 2, so if I multiply 9 by 2, I get 18, and if I do that, I have to multiply the top by 2. 6 times 3 is 18, and then I have to do 5 times 3 also. So my fractions become 5 plus 4 eighteenths minus 3 and minus 5, let's see, 15 eighteenths. Okay, now I can see the denominator is the same, so it's clearly, I'm doing 4 eighteenths minus 15 eighteenths. That's not, there's not enough. And I've got this whole number here, 5, that I can borrow from. So I'm going to borrow from the 5. I'm going to make it a 4. And I'm going to add 1 whole to the 4 eighteenths. But how do I do that? How do I add 1 to 4 eighteenths? Well, I can just say plus 1. But I want to add so that it's the same kind of fraction. So instead of saying plus 1, I'm going to say plus 18 eighteenths. Now here's what it becomes. 4 and 22 eighteenths minus 3 and minus 15 eighteenths. So I added 1 whole to the 4 eighteenths. So it's another 18 eighteenths plus the 4 eighteenths is 22 eighteenths. And now I have the 1 that I borrowed from the 5, made it a 4. I took that 1 and added it to the 4 eighteenths that I already had. And now I can subtract 22 eighteenths minus 15 eighteenths is 7 eighteenths. And then 4 minus 3 is 1. 1 and 7 eighteenths, which is very much what we predicted it would be the answer when we estimated it in decimal form. Okay, so there is subtracting when the fraction part of the whole number, or the mixed number, is smaller than the one you're subtracting from than the one you're subtracting with. And so that's a little bit tricky, something to watch out for. Thank you very much for joining me today, and make sure you practice these a lot. You can do it. Remember that you just need to break these mixed numbers down into improper fractions if you're multiplying and dividing, and just do them really carefully if you're adding and subtracting. Have a great day.